Here we have a double slit. S1 and S2 are the holes or slits. Here we have a monochromatic source of light, which gives light to S1 and S2. S1 and S2 are equidistant from S, so they are in the same phase. We can have two sources of light of equal wavelength. They are called coherent source. These coherent sources will interfere at the screen. We can see a large number of interference patterns having bright and dark fringes. Now we are going to calculate the width of each fringe. The width of each fringe. Here, capital D is the distance between the screen and the slit, and this small d is the distance between the two slits. First of all, let me choose an arbitrary point on the screen. Let me choose a point P here. At point P, light comes from S1, S1P, and this is S1P, and also ray comes from S2 on P. They will interfere, and what kind of a fringe will be made on P. Okay. We are going to calculate the width of the fringe. It may be either a bright fringe or a dark fringe. Here we can see that there is a difference in the path. S1P is shorter than S2P. The difference is called path difference. S2P minus S1P is path difference. Okay. It is denoted by X. X is S2P minus S1P. Let me try to find the expression of this S2 and this S1P, S2P minus S1P. Suppose P is at a distance Y from the center O. This is Y. Let me drop a perpendicular from S1 to the screen. Let it be point A, and from S2P also, S2 also, we have to drop a perpendicular to the screen. Let it be B. OA is D by 2 and OB is also D by 2. The distance between AB and B is D. Now, S1 is the hypotenuse of this right angle triangle. S1P is S1P square is S1A square. S1A square plus AP square. Then what is S2P? S2P is S2P square is S2B square plus BP square. We want to calculate the value of X. First, let us subtract this equation from this equation. It will be S2P square minus S1P square. It is S2B square plus BP square minus S1A square plus, it will become minus AP square. Then what is S2B? S2B, S1A. S1A is D. Okay, S2B is also D. So we have D square plus BP square. What is BP? BP square is Y plus D by 2. BP is Y plus D by 2 whole square minus S1A is D, capital D. D square minus AP square is Y minus D. This is Y and this is D by 2. Y minus D by 2 whole square. D square and D square cancels. Then what do we have? S2P minus S1P square is S2P square minus S1P square is Y square plus 2Y D by 2 plus D square by 4. Then this one all will be negative. No, S square plus S square minus B square. So the second term will be positive. Minus Y square plus 2AB 2Y D by 2 minus D square by 4. Then what do we have? Y square cancels, D square by 4, D square by 4. We have YD plus YD. S2P square minus S1P square is 2YD. Yes, 2YD. We have 2YD. And this is S square minus B square. Factorizing it, what do we get? S2P plus S1P into S2P minus S1P. A square minus B square is A plus B into A minus B. It is 2YD. S2P minus S1P is X. We can replace it with X. So S2P plus S1P into X equals to 2YD. Since the fringes are very small, these angles will be very small. It means S1P and S2P will be almost equal. They will be almost equal to each other. S1P almost equal to D. Almost equal to D. Also S2P. Okay. So S1P and S2P can be replaced with D. Okay. D plus D. This is D. And this is also D. D plus D is 2D. 2D X equals to 2YD. Then we have the path difference. X is YD by capital D. This is the expression for the path difference between S1P and S2P. That is the path difference. Okay. This is the expression for the path difference. In the previous topic, we discussed that for a bright fringe, for P to be a constructive interference, the path difference will be equal to n lambda or to n lambda by 2. Let us use n lambda. Okay, here n lambda, where n is 0, 1, 2, 3. We have the expression of x here. X is YD by capital D. Then we have n lambda. So y is n lambda d by small d. This is the distance of P from O. This is for bright fringe, position of bright fringe. If we put n equals to 1, let it be y1. Y1 is, y0. It will be 0. Okay. Y0 is the distance of the center bright fringe. It is the distance of the central bright fringe. Again, if we put n equals to 1, y1 will be lambda d by d. Then what else? This will be the first bright fringe. This one, the position of the center of the first bright fringe. y2, putting n equals to 2 lambda d by d. This will be the position of the center of the second bright fringe. Second bright fringe. This is first, this is second. It is this. Okay. O, P. P will be here. Likewise, y3 will be 3 lambda d by d. It is the position of the third, the center of the third bright fringe from O. Okay. Let n be the position of nth bright fringe. It will be n lambda d by d. N is replaced with n here. Okay. This is the position of the center of the nth bright fringe. Position of the center of the nth bright fringe. From on either side, on this side or on this side. Okay. Now let's try to calculate the positions of the dark fringes. We know that when the path difference x is equal to odd multiple of lambda by 2, odd multiple of lambda by 2, the position of P will be destructive, that is dark fringe. It will be dark fringe, where n is 0, 1, 2, 3. They are whole numbers. Also, we have proved that x is equals to yd by d. Equating these two equations, for dark fringes, let us use y dash instead of y. Equating these two, y dash will be y dash d by d equals to 2n plus 1 lambda by 2. Then y dash will be 2n plus 1 d lambda by 2d. Okay. This will be the positions of the bright fringe, dark fringes. If we put n as 0, if n is 0, it means y0. Y dash 0 will be 2 into 0, 0. So it will be d lambda by 2d. The central is the center is the bright fringe, so there is no central dark fringe. It will be the position of the first dark fringe on either side. Okay. It is very important. Okay. And also it may be confusing. Y dash 0 is not the position of central dark fringe. It is the position of the first dark fringe on either side of the center O. Okay, it is the position of the first dark fringe. And if we put n equals to 1, we will get y dash 1 d 2 into 1 2 plus 1 3 3d lambda by 2d. It is the position of the second dark fringe, y1. Okay, now let us put the value of n equals to 2. y dash of 2 will be 5d lambda by 2d. It is the position of the third dark fringe. Actually, it is the position of the center of the third dark fringe from the center O on either side. Third dark fringe on either side. 1, 2, 3. The third dark fringe. 1, 2, 3. And if we put n equals to n, y dash of n will be 2n plus 1 by 2d d lambda. Okay. Here y2 is for third dark fringe, y0 is for first, y1 is for second, yn will be for n plus 1. N plus 1th dark fringe. Okay, the position of the center of the n plus 1th dark fringe, not the n net. N is for n plus 1th. It means y7 will be for 8, y8 will be for 9. Okay, and so on. Let us now calculate the fringe width for the central bright, the dark fringes, and the other bright fringes. First, let us calculate the central bright fringe, the width of the central bright fringe. It is denoted by beta naught. It is the distance between this point and this point. The distance of D1 from O is y0 dash, and this D1 is also y0 dash. It will be y0 dash is 2 into 0, 0, 1 by 2. It will be d lambda by 2d plus d lambda by 2d. Adding this, we have d lambda by d. This is the width of the central bright fringe. B naught equals to d lambda by d. For the next one, let us try to calculate the width of the dark fringes. Dark fringe. Let us choose one dark fringe, this one. Let us choose this one, D2. Width of D2. It will be the position of B2 minus position of B1. It is denoted by beta dash. B2 minus B1, position of B2 minus position of B1. B2 is the position of Y2, and B1 is Y1. Yn is this, so Y2 will be 2d lambda by d, and Y1 will be d lambda by d. Taking common d lambda by d, 2 minus 1, we have d lambda by d into 1. This is the width of the bright fringes and dark fringes. Dark fringes, it is d lambda by d. Now let us calculate the width of the bright fringes. They are located between two dark fringes. We can choose any two consecutive dark fringes, D1 and D2. D1, width of D1. It is denoted by beta. Position of D1 is Y0 dash. We have to take this first. Position of D2 is Y1 dash. Okay, since it is n plus 1 and n. Position of n plus 1 is n. Position of second will be Y1 dash. And D1, position of D1 will be Y0 dash. Y1 dash is 1. It is 3 by 2. 3d lambda by 2d, and Y0, if it is 0, it will be d lambda by 2d. Taking common, d lambda by d 2d, 3 minus 1, d lambda by 2d into 2. We have the same expression. This is the width of the bright fringes. Beta equals to d lambda by d. From these three expressions, we can see that the width of the central bright, the dark fringes and the bright fringes are equal. B0 equals to B dash equals to B. So we can write beta equals to d lambda by d. We can say that all the fringes are of the same width. This is the final expression for the fringe width.